Through all the simulations that are going to go through a bid package, aPriori adds them all up and gives us a view on the material requirements. And when I say the material requirements, I mean absolutely everything, including all the material that's going to be scrapped and bought back by the material provider. But this is what I need to purchase in terms of volume. It also calculates how much money is going to be got back from the scrap too. So there's two things that come from this. One is we can plan better for supply and know which suppliers or materials we're going to be buying more or less of, and then choose our regions and our suppliers very carefully to get best cost-effective prices for them. But it also allows us to inform design to say, use more of this material, use less of that material, so I'm not buying much. And therefore, feeding that back into the design process allows us to design for more cost-effective materials, reducing material spend. But it's slightly complicated. Here's an example of two design options that we were exploring. The left-hand component, the original component, we planned to be made in basic ABS, and the other one is one with a glass fill in it. Now we chose ABS for the original design because it's cheap material. The glass one is 11.54% more expensive. So this sounds like it's going in the wrong direction from a design to cost perspective because the material spend is higher. But aPriori told me to go and look at that material and its design to cost guidance, because the cycle time for that material is lower, significantly lower. And the bottom line, therefore, is I reduced the component cost by spending more money on material. That's counterintuitive. And we need this kind of simulation to help us find these opportunities to get the cost down. Of course, if we look across our whole business, we may find more opportunities just like this. And if we focus our design effort on this other material grade that for certain components is better, then we can start to drive a better price for that material and get the best of both worlds. Use that same material here. I get a lower cycle time, of course, and I also get a lower material cost because I'm buying that material more volume now, and therefore my overall impact is 22.4% cheaper. That's huge, just by considering the material strategy and the design at the same time. So if I look at my spend on material, let's say 59 million, and I take 2% out of that by being smarter about decision making, that's a small amount really when you consider it. Then I'm saving 1.2 million going forward. Another way of looking at that is if material prices are starting to rise, I can limit the damage by using this kind of analysis. And we see that today. Over 5 years, decisions that we make on materials in today's money terms are worth $6 million, but that saving could be much larger as material prices go up.